Okay, so lesson 5.3, if you flipped and looked at both sides, there's a lot of questions, okay? We're not doing all of these by any means. What I did is I went through, I looked at the homework, we're picking some highlights to try and put together here. Now, it's all about solving equations. Officially, these are variations of equations you've solved before. We're going to use some of our factoring methods. We've talked about Chapter 4. We're talking about, again, Chapter 5. Factoring with the GCF. Okay, still talking there. Quadratic factoring. When we talk quadratic factoring, basically what they're saying is product and sum, right? If I say PS, you guys know what I mean there, right? Product and sum. Or it could be product of AC. Okay, those different types of things. Quadratic formula could appear. I don't think I need to cover it today because I didn't see it in the homework, but could appear. Differences of squares, where you're taking square roots. And then we've got a couple of special cases. Factoring by grouping. I don't know if you guys know it by name, but you've used factoring by grouping before. You have. I've used factoring by grouping with you. I just haven't called it by the name because we use factoring by grouping within our AC method. And even if you use X method, you're still using factoring by grouping. Okay? So, example. Factoring by grouping. There are 4 terms. How do I often have you guys factor, for instance, in the AC method when there are 4 terms? What do I have you do? Split it in half. Okay, so when you see factoring by grouping, I just kind of want to review this because you will see some factoring by grouping in the homework. Split it in half. Split it in half after the second term. Can I zoom in on this spot so you guys can see what I'm doing here? And what am I going to ask you? GCF of the first half. So ignore the second half. What's the GCF of the first half? X squared. So we're going to write an x squared out front. What goes in parentheses if we divide those by x squared? Okay, x cubed divided by x squared, subtract the exponents, it's x, plus 2x squared divided by x squareds cancel. I have a 2 remaining. Repeat the question to yourself now. GCF, this time it's GCF of the second half. So what do minus 3x and minus 6 have in common? A minus 3. Yeah, don't worry about the equal 0 here. And actually, all I'm practicing is factoring right now. Forget the equal 0 right now. I just want to practice the factoring. So GCF of the second half is a minus 3. So after the parentheses, I write a minus 3. If it was positive, I'd write a plus 3. Minus 3x divided by minus 3 leaves me with x. Minus 6 divided by minus 3 plus 2. You guys know the drill here. Was I successful? I'm successful because yeah, my parentheses match. Now, how do I write my factoring answer here? Jake knows? What do you say, Jake?
Squared minus 3 x plus 2.
Okay. So, x squared minus 3 are my GCFs, so that's one parenthesis. I don't care which parenthesis. Matching parentheses of x plus 2 are the other parentheses. Okay? So when you're asked to factor by grouping, it's what we use within the AC method. I haven't exclusively taught factoring by grouping this year. Should have seen it in Algebra 1, though. I know that's been 2 years ago, though, so I never count on that. Okay? Now, and if this equation, if I'd left the equal 0 here, we would now take each part and set it equal to 0 and solve, right? Watch your directions. You have 8 questions in homework tonight. The first 2 just say to factor. So you stop here. If it says to solve, then we continue. Okay. You guys had time at the beginning, and I asked you to write these 2 formulas down. This is new. Okay, you did not see this in Algebra 1. And this is how to factor the sum or difference of cubes. I say cubes because these pieces are perfect cubes, meaning they are numbers and variables that I can take the cube root of. Now, in all honesty, there's two pieces. There's two examples here. I'm going to do one example here, and then we're going to go solve an example. So, again, I'm just worried about getting the factoring figured out. So, let's try and factor 27x cubed minus 64. So if you can, focus with me here. It's important factoring to know going forward. Here's our setups, right? If you have a cube added to a cube or a cube subtracting a cube, this is a setup we're going to do. Now, in my case, this is a perfect cube minus a perfect cube. So when I set up my answer, which setup am I following? The second one, right? The bottom one. The main thing you have to be able to do is you have to be able to take the cube roots. Do you know the cube root of 27x cubed? So what's the cube root of 27? What? Times itself again gives you 27. 3, right? 3 times 3 is 9, times another 3. So the cube root of 27x cubed is 3x. We're going to do the same thing with the 64. You don't have to worry about the negative right now. Cube root of 64. And technically your calculators can do cube roots. However, trial and error works well too. A number times itself again, that gives me 64. 4. 4 times 4 is 16. Times another 4 is 64. Okay. So right there, that 3x and that 4, those are what are going to go in place of my A and my B in this formula. So the idea is, if this is of the form A cubed minus B cubed, then 3x is the cube root of that. So it's going to go every place I see an A. Cube root of 64, so that 4, that's going to go every place I see a B. So let's try and set this up. A cubed minus B cubed. So first of all, first parenthesis, A minus B. What is the cube root of my first term? 3x. Because my original sign was a minus, the sign in my first parenthesis is a minus. What is the B? So what is the cube root of my last term? What was the cube root of 64? 4. So 3x minus 4 is what goes in my first parenthesis. And that first parenthesis is binomial. It's two pieces. Now, start my second parenthesis. Notice my second parenthesis, it's going to have 1, 2, 3 terms. It's a trinomial here. So the first part says a squared. Here's what I always look at. What did you put in the first parenthesis here? 3x. So what is 3x when I square it? 9x squared. The next sign is always the opposite of the original problem and the opposite of the sign I used in the first parenthesis. So since this original problem was minus, and this was a minus, this sign is now a plus. AB. That is these two cube roots multiplied by each other. So the pieces I put in the first parenthesis, 3x and 4. What's 3x times 4? 12x. Okay. Then the last sign is always a plus, no matter what you're doing. And it's plus right here. This 4, the second item in that first parenthesis, or the cube root of 64, 4 squared. 4 squared is 16. That is how you factor sum or difference of cubes. At this point in your life, guys, I'm providing the formula. Okay, I'm not expecting you right now to have that totally memorized and be able to fill it in. Okay, that's something we'll talk about more in pre-calc and calc, where you have to be able to factor something like that. But for right now, I'm just, can you follow that guideline? That's my goal for you guys today. Okay? Questions on how I did that? Okay. As I said, I had several types of problems I want to do today. And I'm skipping around to try and make sure I match up with homework to an extent. Let's flip to the back side of our notes, if you would, please. And you want to use what I just taught you, or you want to do something different? Okay. Easiest one. Okay. Well, let me break you in to stuff you've seen before. Let's look at H. Again, I'm jumping around today. Sorry. Can you guys find H for me, though? Okay. My job is to solve. Okay? Officially, if you looked at the other side, is what are the real or imaginary solutions of each polynomial equation? Something like this. What would your first guess be if we're trying to solve an equation? When we have powers other than just x to the first? What do you guys do when you see an x squared? Well, okay, so an x squared in x terms, when there's multiple terms. We usually start by setting the equation equal to 0. So let's go ahead and get this equation equal to 0. What does this look like if I make this equal to 0? Okay, so you can either subtract the x to the third, or the other option, because I like to keep a positive x to the third, would you guys be okay if I move the other two to the left? If that's the case, how do we move a positive 8x? You minus 8x. How do you move a minus 2x squared? You add 2x squared. Now, let's put these in order. What kind of order do you think I'm going to put these in? Standard form, highest to lowest. So x to the third plus 2x squared minus 8 equals 0. Okay. Put your factoring techniques to use, guys. What's the first question I like you asking yourself? Is there a GCF? Now is there a GCF, since I've written my problem correctly? Okay, yes, thank you for my mistake. So x cubed plus 2x squared minus 8x all have an x in common. Do they have any numbers in common? No, they just have an x in common. So I'm going to put my x out front. X cubed divided by x is x squared. 2x squared divided by x is 2x minus 8x divided by x minus 8. In my parentheses, still equals 0. Okay, so I GCF'd it. In those parentheses, think about the different factoring techniques we commonly use. Can those insides factor? Okay. Could we maybe product and sum this? That's a technique I expect you guys to know at this point, right? Learned that back in Algebra 1. We reviewed it. Okay. So let's think product and sum. A product of what? Your C term, which is negative 8. And on x squared, it's just a 1, right? So do I need to use AC here? No. You will see a couple of productive AC terms or problems in homework tonight, though. Even if I don't get you an example of them in class, you will see that. Sum. What's the sum I need? 2. What multiplies to be negative 8 and adds to be 2? It's a combo of 2 and 4. If it multiplies to be negative, I know I need a positive and a negative. If it adds to be positive, what's that tell me? Yeah. Bigger number is positive, so negative 2 plus 4. What do I do with that negative 2 and plus 4? Put them in parentheses. Now, what about this x out front? Carry it down. Do not lose it, because that represents an answer, guys. 2 parentheses, because we know x squared breaks into x and x. We said our numbers were minus 2 plus 4, or plus 4 minus 2 if you prefer. What's my technique here now? Set all 3 equal to 0, right? You saw some of this on the test. Now, notice we did say all 3, so that means x equals 0, x minus 2 equals 0, and x plus 4 equals 0. So what are my solutions? 0, 2, and negative 4. Okay, and that's it. Okay, you have one like this in homework, guys. I was organized this morning. I went through and checked. Might not hit it until number 8. I think it might be the very last problem, but you have one like this in homework. Huh? In homework, 8. So. Okay. Let's go. Let's go left. I want to look at G. And then we'll go do a cubic. So G. X to the 4th minus 16 equals 0. Okay, what's the first factoring question I should ask myself? Is there GCF? Okay, no GCF. I checked, though.
Yes.
Now, let me ask you a question. If this said x squared minus 16, could you factor it?
Yes.
Do you remember how? How does x squared minus 16 work? The square root of x squared is x. So that breaks into the first parentheses, right? Square root of 16 is 4. And what about these signs? If it multiplies to be a negative, plus or minus, right? That is what we call factoring the difference of squares. That's one of your techniques I expect you to know. Now, what's different on this problem? It's x to the 4th. Can you take the square root of x to the 4th? Can you divide that exponent in half?
Sure.
Yeah. So we're going to use our difference of squares technique. Follow along with me. These are both pieces I can take the square root of. So I'm going to set up 2 parentheses. X to the 4th. You can either ask yourself, how do I break up x to the 4th? Or what's the square root of x to the 4th? And that is x squared. Because when you take a square root of an exponent, you're just cutting it in half. What's the square root of 16? Still 4?
Yes.
And how do you multiply to get negative 16? Still a plus and minus. Okay. There's 2 different directions we could go next. Anyone have any thoughts? Okay. We have 2 pieces multiplying to equal 0. Can we set them equal to 0? Okay, let's do it. X squared plus 4 equals 0. X squared minus 4 equals 0. How do we solve for x when there's just an x squared? Okay, we want to get the x squared by itself, right? There's just an x squared term. Get the x squared by itself. So it's x squared plus 4. We're going to subtract 4. X squared equals negative 4. Same thing on the other one. If it's x squared minus 4, we're going to add 4. So I have x squared equals 4 on one, x squared equals negative 4 on the other. How do I solve when it's x squared equals a number? Take the square root, yes? Let's start over here on the positive one. If it's x squared equals 4, what's the square root of x squared? X. What's the square root of 4 in an equation setting? 2 and negative 2. So right here, plus or minus 2 for that part of the problem. Okay? X squared equals negative 4. So again, we're going to take the square root. Square root of x squared is x. Square root of negative 4. Those i's still hanging around, guys? What happens when there's a negative under it and you take the square root? Okay, so first of all, the square root of 4 is still 2, right? The square root of that negative makes this a 2i. We're still in an equation setting, so we still have to answer plus or minus 2i. How many answers did I just have on that problem? 4. Notice, what was the original power or degree of this problem? X to the 4th. On H over here, what was the highest power on the original problem there? 3. How many answers did I have? 3. Okay? So that highest power always tells you the total number of real and imaginary answers together. Now, let's go F or I, F or I. I'm probably not going to have time for both. You want to do I?
I agree.
Okay, I it is.
I disagree.
Okay. Hey guys, you see parentheses. What's your brain tell you to do here? Distribute. So distribute both sides. X to the 3rd plus 8x equals 8x plus 8. I see stuff that maybe has to be factored.
Yes.
So we should probably make our equation equal to 0.
So it's going to be third.
So I'm going to subtract 8 and subtract 8x over. Okay, so I still have x cubed. 8x minus 8x, 0. And then we still have a minus 8. Okay, guys, here's the deal on this one. Do not go with the idea of, oh, if I move that 8 over, it's x cubed equals 8. The cube root of 8 is 2. I've got an answer. My answer is 2. What's my power on this problem? The highest power is x to the 3rd. How many total real and imaginary answers are you expected to find then? 3. Here's what I'm going to tell you. If you just take the cube root here and just get an answer of 2, you have found the one real answer. Okay? But our directions are asking us to find all real and imaginary. Okay, guys, I showed you that factoring at the beginning for a reason. You remember that? We're using it. So, unfortunately, it's on the front side of your notes, so you're going to have to be flipping back and forth or here. The factoring we're going to use, this one is what? In the form of a cubed minus b cubed. A minus b, a squared plus ab plus b squared. There you go. It's on the board so you don't have to flip back and forth. Got it? So first things first. Let's figure out our a and b. Maybe you don't need to write this down, but I'm going to write it down. What is the cube root of x cubed? What happens when you take the cube root of x cubed? You get x. That is going to work as the a. Because again, remember, you're doing a cubed minus b cubed. So that right there is going to work as a. What is the cube root of 8? 2. Guess what the 2 works as? That's your b value. Does that make sense what I'm doing there? I don't really like how I set that up just now, but the information is there. So, every time I have an a, I'm filling in x. Every time I have a b, I'm filling in 2. Okay, my first parenthesis is a minus b. What was the cube root of x cubed? X. Minus, because that's what the original problem was. What's the cube root of 8? 2. So x minus 2, or a minus b, goes in that first parenthesis. Second parenthesis, this is the trinomial. First of all, it says a squared. So whatever your first piece in the parenthesis was over here, x, we square it. Or if you labeled it a, right? My original problem was a minus, so now this sign is a plus. A times b. So, the two pieces here in this original parenthesis were my a and b. 2 times x is 2x. Last sign is always a plus. B squared. So 2 squared, which is 4. Okay. Now factoring is doable. I know it's new to you, but I hope you see it as doable. Okay. I have 2 parentheses multiplying to equal 0. How do I continue solving? Set each part equal to 0. And I guess I should have, officially, my brain probably wants to say, can I product and sum this parenthesis over here? I'll tell you what, though. You can't. Okay, when we did this cube thing, you can't. You can't multiply to be 4 and add to be 2. It's just not possible. If we can throw negatives in there, sure, but there's no negatives in there. So, set each part equal to 0. X minus 2 equals 0. X squared plus 2x plus 4 equals 0. You want to get the easy one out of the way? If it's x minus 2, you add 2. We just found an answer to be x equals 2. That's one answer. That's the answer we had before we did any of this crazy factoring, right? Okay, x squared plus 2x plus 4. We can't product and sum it. It doesn't work. What's our backup plan when we can't factor something using product and sum to solve? No?
No.
It's not going to factor at all.
Oh.
So what's backup plan when something can't factor, but yet we still need to solve it? Got it, Carolyn? No? Because that would still be factoring. No? What else did I hear back here? Quadratic formula. Here we go.
No.
Okay.
Just
Yep.
call it a day.
Quadratic formula. Okay. X equals negative b, so that's going to be negative 2 plus or minus the square root b squared, so 2 squared minus 4 ac. So 4 times 1 times 4 all over 2a. 2 times 1. Clean it up. Negative 2 plus or minus. What's going on under that radical? 2 squared is 4. 4 times 1 times 4 is 16. What's 4 minus 16? Negative 12. So I have negative 2 plus or minus the square root of negative 12 all over 2. Okay, guys, side note. What do you know about the square root of negative 12? 4 and 3, and there's an I because of the negative. So if I think about this as negative 1 times 4 times 3. The square root of negative 1 is going to become an I. The square root of 4 is going to become a 2. The square root of 3 stays. So this becomes 2i square root of 3. So I have negative 2 plus or minus 2i square root of 3 all over 2. Last step. Can I simplify that?
Yeah.
What do these all have in common? A 2. Can all three terms divide by a 2? Yeah. Out front, what is negative 2 divided by 2? Negative 1. Plus or minus 2i radical 3 divided by 2. The 2's cancel and I have I radical 3. So I wrote, sounds like I'm off the screen, negative 1 plus or minus I radical 3. And don't forget, what was the other answer we already had? X equals 2. How many answers did I end up with?
2.
3?
3.
Why 3?
I don't know.
The plus or minus. Negative 1 plus I radical 3 is an answer. Negative 1 minus I radical 3 is an answer. Okay, guys. I think I got you a little bit of everything except product of AC.
We don't have time.
Okay? No, we don't have time. Product of AC, we've practiced it lately. I will warn you, the product of AC, I saw 2 problems. The numbers are a little bit bigger. Okay? I will warn you there. Lesson 5.2, no, 5.3 in Math Excel. My plan is to do some 5.4 tomorrow, and then do a little Chapter 5 review.